Okay, pre-cal students, this is to help you go over your quiz mistakes on your quizzes. Remember, every single problem on here you might not have missed. So if you missed numbers like 10, 12, and 15, then just look those problems up, okay? I've worked out all the problems on here that everybody missed as a whole together. All right, let's take a look at number 7 on your quiz. We're going to simplify. When you're multiplying like bases, you write the base once and you add the exponents. Hopefully we know that by now. A positive 2 and a negative 7 would be a negative 5. All right? And then, of course, we want no answers with negative exponents, so we bring the x and the negative 5 down to the bottom, and it becomes x to the positive 5. There's nothing left up top, so we put a 1. You've got to remember to eliminate or get rid of negative exponents. Number 8, we're multiplying like bases, so we write the base once, and we add our exponents. Negative 9 plus 9 is 0. I think I gave you credit for that, but really you should have taken it a step further. Anything to the 0 power is 1. Not into the 1, just 1. So the real answer is 1. Now I gave credit for this. Some of you thought that 9 and negative 9 gave you a 1, so you had into the 1 power, and that's not right, okay? When you add a 9 and a negative 9, you get a 0. Let's take a look at number 9. We're going to go ahead and multiply these two polynomials together. First of all, you multiply the coefficients. So 3 times 4 is 12. And then you add your exponents because they're both y's. Y to the 4th times y to the 3rd. And that would give you y to the 7th. All right? Moving on to the next problem. Don't think that's supposed to be there. Hope we're not missing a problem anywhere. All right, number 10. All right, when you're dividing like bases, remember what to do. You do not write the base in the denominator. No, you write the base in the numerator, and you subtract the exponents. You start with the top number and subtract the bottom number from it. So it would look like this. Negative 24 minus a negative 21. Now, if you need to use a calculator because you're weak with your sign numbers, that's fine. Hopefully you can do this, though, okay? At y'all's age, you should be able to. But a negative 24 and a positive 21, you would get a negative 3. Now that would normally be your final answer, but the directions said to have no negative exponents in your final answer. So what you would do next is you would bring the y to the negative 3rd down to the bottom, and when you do, the sign changes, and there's nothing left up top, so we do put a 1. All right, let's continue on to number 11. All right, now we're going to take this 4, and we're going to multiply it times all of the exponents. Now don't forget there's a 1 right there with a 3. So we're going to multiply that 4 through. Now I think it would help a little bit, and there's a little bit of background noise. Again, I'm making this video on a Saturday morning, and so the kids are playing and doing stuff like that. All right, that's going to help. Lucas, I'm doing a video, buddy. Please be quiet. Thanks. That's fine. Okay, guys, again, we'll be a little more informal. I'm going to put a 1 right here. I'm going to take this 4 and multiply it through. I'm calling this a 2. Now, if you looked at it and thought it was a 3, and I took off for that, you let me know. I will change your grade. But I'm looking at this as a negative 2 right here. We're going to take this 4 and multiply it through times all the exponents. So 4 times 1 would be 4. 4 times 5 would be 20. 4 times negative 8 would be negative 32. And 4 times negative 2 would be negative 8. There. That's not too hard. That's really actually pretty easy compared to some of the other ones that we've done in the past. Okay, not having a lot of success. There we go. All right, let's continue on. Now, up top, 3 to the 4th. 3 times 3 times 3 times 3. That would be 81, I believe. 3 times 9, 27. Yes, 81. Now, this x to the 20 is fine where it is. And it's fine because this 20 is positive. But if you look at the y, it's got a negative exponent, so I'm going to bring it down here and make it y to the positive 32. And if you see this z, it has a z to the negative 8. I'm going to bring the z up top and make it a z to the positive 8. And we are good to go. Moving on to number 14. Now, this is scientific notation. I want you to write it in standard notation, so 5.9 times 10 to the 5th. That means we're going to move the decimal. It's a positive 5 right here. That means we want the number to be big, so we're going to move it to the right. If you move it to the left, we have a real small number like 0.000, something like that. So we're going to move the decimal to the right 5 places because I have a 5 right here. So here we go. 1, 2, 3, 4, 5. Some of you put an extra 0 in here, and you had 5,900,000. And the final answer is 590,000. I hate that you missed a problem like that. It was pretty easy, but that is what some of you did. All right, let's go back. Let's go ahead to number 16. Okay, when you're multiplying scientific notation numbers, what I've taught you to do is you take these two numbers and you multiply them. So 9 times 8 would be 72. And then what I've taught you to do is you add your exponents. So times 10, you have a 7 and a negative 3. If you add those, you will get 10 to the 4th power. Now this is not a sufficient answer because you want your decimal to be here, and it's not. It's right here. So we're going to have to take this decimal and move it to right here. So we're going to move it one place, 7.2 times 10 to the 4th. And now we're either going to add 1 or subtract 1. And that's where some of you made your mistake right there. And what you got to remember is this. You had 72. That's not 0.72. 0.72 would be a small number, less than 1. You've got 72. That's a big number. So we're moving that decimal, and that's a positive movement whenever you're dealing with a big number. So we are going to add 1, not subtract 1. And so my final exponent here would be a 5. And that is your final answer. Okay, number 17. Whenever you're dividing numbers that are in scientific notation, you first of all take these two numbers and you divide them. So 1/4, 1 divided by 4 is 0.25. And then with your tens, you subtract the exponents. So 7, or excuse me, with division, you subtract the exponents. So 7 minus a negative 2. 7 minus a negative 2, and that would be 9. Now this is not a sufficient answer. You would like your decimal that's right here, you would like it to be right here. So we're going to have to move the decimal one place. So now I have 2.5 times 10. Now the only problem is, am I going to add 1 to this 9 or am I going to subtract 1? That's where a lot of you are confused. Well, look back at your original number before you move the decimal. It was a point number. It's less than 1. So whenever you're dealing with a small number, that's a negative movement. Hold on one second, guys. My son has a question. Yes, what do you need?
Where's Mom?
She left. She's gone. She's at her school.
Wait.
Okay, I'm back. Again, I told you there'd be some interruptions today. All right, here we go. Because it was 0.25 and we moved it to the right, that's going to be a negative movement. And so your final answer is 9 minus 1, and that will give you an 8 for your final answer. All right. Okay, I've got a positive sign in front of this parenthesis, so none of my terms on the inside change. They all stay. None of my signs change. They all stay the same. Here I've got a positive in front of this parenthesis here, so none of those signs change. They all stay the same. These are not difficult, but they're definitely tedious. Okay, there's a negative sign here, so I'm going to change all of my signs inside of that parenthesis. So my positive 3 would become a negative 3. My positive 4 would become a negative 4. And my negative 15 would become a positive 15. And now you simply look for like terms. Here's an x squared term. Any other x squared terms? There's one. There's one. 3 of them. Oh, here's one, Mr. Earhart. Right here. That's a y squared. And plus there's an x there too, so that's not right. Okay, a 2, a 5, and a negative 3. Positive 2, positive 5, negative 3. That's going to give me a 4x squared. And I'm going to cross these 3 terms off right here. And now we'll move on. Look at our next term. All right, our next term here is 12xy. Any other xy terms? Here's one. And here's, no, I almost said this was 1. It's not because it's y squared, so that would have been a mistake. Okay, I see 2 xy terms. Positive 12, negative 8. That's going to be a positive 4xy. Done with that term, done with that term. Now here's a constant term. Any other constant terms? Here's one. Here's another one. Those 3 are all constant terms. They have no variables with them. So a negative 11, positive 12, positive 15. That would be a positive 16. Now hopefully your sign numbers are good enough that you don't need a calculator, but if you do, you do. That's fine. It would be a positive 16. And now we're down to just one term, so bring it on down. There's no like terms to put with it. Negative 4xy squared. I don't like these problems. They're really long and tedious, but they're not hard, though, that's for sure. Okay, moving on now to, I'm not sure I meant to do that. Let's see here what's going on. This is number 18, 19. All right, let's get rid of this slide. All right, number 19. Now notice here the two parentheses are side by side, so they're multiplying. I'm going to take this n. There's no plus or minus sign right here between the two parentheses. Okay, and that's what I mean by that. They're multiplying. So this n gets multiplied by all three terms. So n times n squared is n cubed. N times negative 6n is negative 6n squared. And n times negative 4 is negative 4n. There, I'm done with that. Now take your positive 1 and multiply it through. All right? 1 times n squared is n squared. 1 times negative 6n is negative 6n. And 1 times negative 4 is negative 4. And now we just look for like terms. Here's an n cubed term. There's no other n cubed terms. Here's an n squared. Here's an n squared. Notice it's a positive 1. There's a 1 right there. So a negative 6 and a positive 1 would be a negative 5n squared. Cross those off. Now I've got an n term and an n term, a negative 4 and a negative 6. That would give me a negative 10n. And then the only term I have left that does not have a like term would be a negative 4. And there we go. That's it. Multiply and then simplify. Okay, moving on to 20. We have 5x plus 2y. Excuse me, that's to the second power. And so we're going to write the parentheses twice. Okay? And so here we go. Take this 5x and multiply it by both terms over here. 5x times 5x is 25x squared, and 5x times 2y is 10xy. Now I'm going to take this 2y and I'm going to multiply it through. All right? So 2y times 5x would be 10. You're welcome to put yx, that's fine. And then 2y times 2y would be 4y squared. Now, I see only one x squared term. I see only one y squared term. So we're going to have to bring those down. There's no like terms. But in the middle, notice I have an xy and a yx. They're the same term. xy is the same thing as yx. Excuse my voice. Let me get a drink of water here real quick. Okay, I am back. Hopefully that will help my voice a little bit. Okay, so a positive 10 and a positive 10 is a positive 20 xy. By the way, if you put positive 20 yx, I would give you credit for that. Most books are going to put it in alphabetical order, x first, then y, but it's really not a big deal to me. Okay, moving on to number 21. Look at this polynomial and state how many terms it has and what the degree is. Okay, well, first of all, I see one term, then a minus sign, another term, then a plus sign, and then another term. So first of all, there's three terms. Now, hopefully you know that by now. Positives and negatives divide an algebraic expression up into terms. So I have three terms. Now, the degree is where it gets a little tricky. Okay, I'm going to write this really big. 7ab cubed minus 11, if I can get it to work here, a squared b to the fourth positive 8. Now, whenever you're looking at the degree, do not look at the powers of the numbers, the coefficients. I don't care what the power of the 7 is. I don't care what the power of the 11 is. I don't care what the power of the 8 is. You're looking at the variables, the letters. And if you'll look right here, the b has a power of 3 and the a has a power of 1. So you add those two together, and for this polynomial, for this term right here, the degree would be a 4. Now look at this term. I have a 2 and a 4 for my exponents. Add those together. The degree of this term would be a 6. And of course over here, the degree of this term would be 0 because you don't have any a's or b's. So it's so simple now. Do you see where the 4 came from? 1 plus 3. Do you see where the 6 came from? 2 plus 4. Do you see where the 0 came from? There's no a's or b's. Which number is bigger, 4, 6, or 0? Well, that's a pretty easy question. The answer is 6, so the degree is 6. You go with the highest number, okay? All right, moving on to 23, factor by grouping. So I'm going to pull out what's common in the first two terms. There's no numbers that are common, but I can pull out a z squared. So if I do that correctly, I'm left with z plus 3. Now look at these last two terms. I'm going to pull out what's common. There's a 3. I can factor out, but don't forget, whenever this sign is negative, then you must pull out a negative sign right there. So I'm really pulling out a negative 3. Now please watch your signs. A negative 3 times what would give you a negative 3z? Well, it would be z. Check and see. Negative 3 times z is negative 3z. Now you want a negative 9, so you want to put a positive 3 here. Why, Mr. Earhart? Well, because look, a negative 3. If you were to multiply this negative 3 back through, a negative 3, excuse me, a negative 3 times a positive 3 would give you a negative 9, and that's what you want. You want to put a number right here so that when you multiply this number back through, you get what you started with up here. That's your goal. All right, your parentheses do match, so you write your matching parentheses once, and then you're left over with z squared minus 3. All right, moving on to number, is that the last one? Hey, the last one. All right, good deal. I hope this has been a help to you. Call or email if you have any questions.